Hello, everyone. How are you doing today? Thank you for joining us very much in the first of our three-part webinar series that will be taking place over the next couple weeks. My name is Liam Meyer, and I'm a Senior Customer Success Manager at GreenValley International. My job is to work with our global network of partners and customers. We have customers in 6 continents and partners that help us service them all. Whether you're in China, Australia, Brazil, US, Canada, or anywhere in Europe, GreenValley International has a partner or a representative nearby. Some partners that we like to highlight, and this is not an exhaustive list, and many are growing day by day, include some of the suppliers we have to actually manufacture our hardware equipment, as well as distribution channels and special relationships with institutions of higher education and government. A little bit more about GreenValley International. So we were founded in 2012 in California, and the original name of the company was True Reality Geospatial Solutions. At that time, the company was largely involved in developing algorithms for processing UAV LiDAR data, fixed wing LiDAR data, and data that was captured in forest environments. So one of the products that came out of this period of time in the customer's development was our LiForest product, which is now incorporated fully into our LiDAR 360 software, which I'll talk about later in this webinar, as well as our beginnings of our LiAir series, which has since grown to include more than just the Regal and Velodyne LiDAR sensor designs that we initially started off with. In 2014, we released LiDAR 360. This is really a cutting-edge point cloud post-processing software, meaning after you've gotten your point cloud all registered and built, then you have to get into the portion of the workflow that actually gets you closer to your deliverables and the things that your customers are after. This was released in 2014 and has since gone continual developments until most recently when we released LiDAR 360 version 4.0. I won't dive too deep into that today. I'll reference it a few times throughout this webinar. I'll actually show some screenshots taken from the software. But really, that's what the second part of this three-part series is dedicated to, is letting you know more about the advancements that have been made in LiDAR 360 up until the present point, which is LiDAR 360 version 4.0. Then, in 2017, we released our mobile terrestrial LiDAR scanning solution, our LiBackpack. At that time, it was just a single sensor system. And since then, we've added more sensors. We've improved the software that is used to process the data. And it's really become a turnkey solution for anybody who's looking to get into SLAM-based mobile mapping at a very easy to use and approachable type level. So you can see in 2018, we innovated on the LiBackpack, which I just discussed, was introduced the previous year. We added dual sensors to it. And we also released some pre-processing software, specifically our LiAcquire PPK, and as well as our LiGeoreference. And this is a really important portion of any LiDAR workflow, is to actually get your data, whether it be the raw or final point clouds, into a target spatial reference system so that point clouds taken at different points in time but are overlapping align, as well as just overlapping point clouds. They align as well. Then in 2019, we released our LiBackpack C50, which incorporates a color camera, as well as the post-processing software for that design, as well as our other LiBackpacks called LiFuser, and our LiBackpack DG50. So the D stands for dual laser sensor, the G stands for GNSS or GPS module, and the 50 is just a reference to the type of sensor that we use, which in the case of all our backpacks, will be the Velodyne VLP16. I'll dive more into the specifics of the backpack later in this presentation. We're going to be jumping now into the actual meat and potatoes of this webinar here. So GreenValley International, what do? We provide turnkey solutions for 3D mapping and surveying. This involves quite a few different types of products, both hardware, software, And since this can be a very advanced technology, or in some cases just a technology that many are used to, we provide types of services that include demo, training, and even data processing in specific situations. So what do these solutions provide? What are their value propositions in the sense? First of all, we are providing 3D data in high definition, whether it be from our vehicle, our backpack, our UAV, or any of our different platforms. It's all going to be what is considered high definition data. This means that your point cloud data will really represent in a very high fidelity way the objects of area of interest in which you're trying to scan. We also provide data fusion opportunities. So one of the interesting things about LiDAR systems is that when you mount them to different platforms, let's say it's a UAV or a drone system, you're going to get a very top downwards looking view. Whereas if you put it on something like a backpack or a vehicle, you're going to have more of a terrestrial type view or a side view on objects. So when you fuse all these different types of LiDAR data together, or I should say the same type of LiDAR but collected from different vantage points, you'll get a much more complete 3D model. Also, you can then fuse, since all of this data is georeferenced, or because you know where your camera is relative to the LiDAR sensor, you can create what are called colorized 3D point clouds. Or conversely, you can provide depth mapped imagery, as you see in the lower right corner here on the right hand side. And this allows you to actually take distance measurements within your pictures, which is quite a useful thing. And then finally, what do we really provide are deliverables. Oftentimes, the point cloud is just the beginning of somebody's workflow. They have to then take that through a data cleaning process. They have to then just pick out certain areas of interest, and then they have to actually get it into a data type format or visual that their end customer or colleagues need to actually make use of the point cloud data. So what we do in the sense of being turnkey is we take you all the way through the collection of this 3D data in HD, the post-processing that's going to allow you to properly fuse different data sets, and then generate deliverables that actually make real impactful value on your investment on the LiDAR systems and 3D mapping in general. So the first product line of all of our hardware systems I'd like to talk about is one of our originals, and that's our LiAir series. These UAV LiDAR systems, which stands for Unmanned Aerial Vehicle, sometimes also called a drone. There are many different acronyms for this these days, but the point is what we're talking about here is an unmanned multi-rotor or fixed-wing platform that usually flies, within line of sight of a person, and increasingly, as certain regulations allow, beyond line of sight, that has the ability to lift payloads that are lighter, and in fact must be lighter than something like a fixed-wing aircraft or a manned helicopter. So we break our product line really down into 3 different levels of systems. In our entry-level systems, which are more entry-level in terms of price and capability can still be quite high, would include our LiAir 50 as well as our LiAir V. And then we get into our mid-range systems, which are very capable of better quality data than you're going to see from our entry-level systems in some situations. But really, this system is designed for its ability to collect distance measurements from targets that are located farther from the sensor than you could achieve with something like the LiAir 50. It also has the ability to scan at larger angles from nadir, which is the center line underneath the platform as it moves forward during data collection. And in this way, it can do some side scanning, and that's one of the benefits of actually our mid-range LiAir 220 systems. And then finally, you get to the high-end systems that we work with, and these are all going to feature Regal sensors, and that's going to be our LiAir 250, which has the Mini Vox 1, as well as the LiAir 1000, which has the Vox 1 sensor on it. This photo is taken near our offices in Berkeley, California, which is where I'm located out of. It's actually at a place called Treasure Island, and you look out in the background, you see the San Francisco skyline there. And this is actually a great place. We have taken clients out to in the past. We can go here and do some calibration work. It's just a site that means a lot to us in our company, and our ability to service customers here in North America and around the world. So why do we make all these different systems? Well, one of the underlying reasons is because not all LiDAR is created equal. You have something like on the far left there, which is the Velodyne VLP-16, also sometimes called the puck, and then the VLP-16 that's more the canister look like. So excuse me, that's the 32. There's a typo there. And then you get to something like the mid-range, which is going to be the Hesai Pandar 40 sensor. This sensor is largely similar to Velodyne design, but instead of having 16 channels or 32 channels, it's going to have 40 different channels. And it's also going to have the ability to range up to 220 meters, where your Velodynes are going to be looking at a max range of more like 100 meters. And then you move farther out to the right in this graphic and you get into the Regal systems. These are our survey grade level instruments that we're going to be working with here. The Minivux 1 is light enough to be integrated into a payload that can be placed on an M600 Pro, as well. And then you move over to the right and you get something like the Regal Vux 1, which is going to be in our LiAir 1000 series, and is going to be more well suited for helicopter survey. So one sensor I have not shown you there is our LiAir V sensor, which is actually a LiBox sensor. It's a mid-40 sensor. This is one of the newest LiDAR sensors on the market, and we actually were at CES this year, the Consumer Electronics Show in Las Vegas, Nevada, to debut this at the LiBox booth. We're now integrating their sensor into our ultralight solution for UAV LiDAR scanning. So this compact, lightweight design is actually quite high accuracy. We're looking at an absolute accuracy in the vertical dimension absolute of about 5 centimeters. Horizontal accuracies, being LiDAR data, are generally, if not always, better than vertical accuracies. And then what we're looking at there is about a precision level of also about 5 centimeters. So that will come into play as you take relative measurement in your point cloud, or try to pick points with greater certainty in location. So what else is nice about this is it's a very attractive price point, not only relative to the rest of our systems, but also to other systems on the market. And one of the reasons why is it's really been stripped down to include just what you need for a LiDAR survey. There's no telecommunications technology as maybe as you're going to see with some of our other systems that will give you something like a real-time display. It's also one of the things about it is that it's going to kind of have no camera on it, at least in this model. In the future, we'll probably innovate once we find an appropriate camera to do this, but we have a flexible design that will allow such upgrades to occur in the future. And lastly, it's just easy to use. You can see here that there's a light word panel on it, those blue dots, LED lights. Those are just going to be your system status indicator lights. There's one button that's going to power on the system. You hold that down for 2 seconds. You hit the button again for another 1 second to start collecting data. When you're done with your mission, hit that button again for 1 second. Stop collecting data. You can either then repeat the 1 second press to start a new data collection, or you can hold it down for 2 seconds and just turn it off. Very easy to use, very consumer friendly, and a very approachable system for those who are new to LiDAR or someone who's just looking for something simple to get the job done. So this you can see is what the LiAir V looks like mounted to the DJI M210 RTK platform. We developed a mounting kit for this system, and it's actually a very capable little tool for this system, especially if you've already owned this platform and you're doing imagery works and photography work. It's nice that you don't have to replace your drone to get into the LiDAR game. Many of the sensors out there now are still requiring something that has a little more lift capacity, something like the M600 Pro. So to dive back into some of our other LiAir models, what you can see here is our LiAir 50, which features the Velodyne sensor. You also see the LiAir 220, which is going to feature the Hesai Pandar 40 sensor. This sensor is going to have a longer ranging capacity than the LiAir 50. All these models are going to see here have the ability to be mounted to the M600 Pro. And then lastly, on the far right, we see our LiAir 250. This reaches the Regal Minibux 1 sensor. So just to take a step back for all those who are somewhat maybe newer to UAV LiDAR, this are basically the core components of any LiDAR system. First of all, you have your LiDAR sensor shown there on the bottom side. This is the Hesai Pandar 40S. This is actually going to be what's taking your range measurement. Not with an arrow here, but very important, it has the GreenValley logo on it. Situated right underneath the middle of the aircraft is going to be the LiAir main body. This is going to be where we have all of our integrated circuit boards and firmware and all the different things that we need to take sensor information, combine it into a nice file package that's easy for customers to work with. You'll see there's also a GNSS antenna here. So one of the things about UAV LiDAR is it's called directly georeference point cloud data. And one of the reasons why it's called this is because you take GNSS information, you differentially correct it using some base station information that you collect from somewhere nearby. GreenValley also makes its own base station, so if you don't have something available to you where you can get, say, a Rhinex file out of, you can use our base stations for very easy workflows and easy post-processing workflows as well. And then you can see that there's also incorporated into these devices as an optional true color camera. So this is, for most of our designs, is going to be a Sony a6000 RGB camera. It's going to be great for creating colorized point clouds. And you can also interestingly use our LiMapper software, which I won't get too much in here today. But it's basically a software with a photogrammetric engine in it, so that you can use your trajectory information or the information that's collected from the GNSS antennas, as well as something called an inertial measurement unit, which measures the acceleration as well as in which direction it's accelerating in of the actual payload at all points in time to create something called a trajectory, sometimes also called pose data. Pose standing for positional, right? Position is going to have in it things like your latitude, longitude, and elevation, as well as your attitude. And attitude is simply something that involves your yaw, your pitch, and your roll. So it can take that pose data, that trajectory data, geotag the images, and then use these images as an input to a photogrammetric engine to create digital orthomosaic models. So the beauty here is having the true color camera integrated, really at the end of the day, is that you have to only fly one flight to collect both the imagery as well as the LiDAR data that you're going to use later on to generate a photorealistic point cloud, which will have extra information in for you than just the raw 3D geometric data that would be contained in the LiDAR itself. So lastly, I want to just introduce you to, or not lastly, second to last, I should say, here in our LiAir series, is our LiAir 250. This is really the workhorse of the UAV product line that GreenValley International creates. It was designed by surveyors for surveyors, has a maximum range capacity of 250 meters. It can generate multiple returns per pulse. There's integrated color camera. This is the tool that will get the job done when accuracy is of utmost importance and precision as well. Here's a little video that we have. It's available on our website as well. I encourage you to take a look at GreenValley's YouTube site and find out more about our products and monitor it continuously. We're always adding new things about existing products that we have or products that we're going to be releasing. This video is going to just show you essentially what data collection operations look like with the LiAir 250 mounted on the DJI M600 Pro. Here we're using DJI's ground station Pro to do flight planning, but we're monitoring the actual data collection from our LiAcquire software, which is a specialized software that comes with all of our LiAir systems. And these are what the data looks like that you actually can collect. There's a lot of different great use cases for our LiAir system, specifically the LiAir 250. One of the areas where we've been seeing a lot of interest is in the Powerline corridor survey. So this is basically looking for danger points or clearance zone violations along electrical utility corridors. You can also use this same technology if you're going to say investigate oil and gas pipeline right-of-ways. Another way that this Regal sensor is really well applied is in topographic survey, as well as in the survey of agricultural plantations or croplands, where you're trying to measure with a very high level of accuracy and confidence the height of crops and individual trees. Topographic survey, where once again you're really trying to get very precise information about elevation, as well as in forestry, because the multiple returns allow you to really penetrate that canopy with each LiDAR pulse and kind of scrape out any sort of information you can about the spatial structure of not only the underlying ground, but maybe the mid-strata and upper canopy regions at the same time. And that's because Regal has this ability to generate multiple returns per pulse. And then there is our manned helicopter option here. So this is going to be our LiAir S1000. This features the Regal Vux1 UAV. This is once again for a manned system, so it's not a drone, it's not a UAV. There's mounting kits available for the nose, for the underbelly, and really, depending on where you are in the world, you probably have specific certifications that are needed to work with these equipment. So this is really important that you reach out to us directly if you're interested in LiAir S1000, so we can hook you up with our local partners or work with you very directly to get this product in your hands and make sure that you have all the things in place you need to be successful with this very, very high performance machine. Really the benefit here over something like the 250 is going to be the ability to scan larger areas simply because you're on a fixed wing helicopter powered by gas or just some sort of jet or helicopter fuel, versus a lithium-ion powered UAV system that's going to have a maximum flight time of maybe 20 minutes or so. So this is going to be able to collect a lot more per job, and also the Regal Vux1 UAV is going to really have the ability to give you a lot more distance on range here. So it's also the Vux1 as well here. LR is something that will integrate into this system. So this is our LiAir S1000 series. Please reach out to us at info@GreenValleyInternational.com. That's abbreviated INTL.com. And we will be happy to set up a meeting with you to discuss your specific project parameters and your needs if you're interested in this high-end system produced by GreenValley International. So one of the nice things about GreenValley that probably sets us apart in many ways from other integrators in the market is our dedication to not only developing the hardware solutions, but the software solutions that need to accompany them. And this is well represented here in a software we produce called LiGeoreference, which has our live nav module included in it. And I'll talk a little bit later about what live nav means, but as you can see here, this is a very easy to use interface. It allows you to just bring in your project folder that you downloaded directly from your LiAir system. It's got all the different folder structures implemented in it, so it's real simple. Click button where you can just hit start, and we'll first generate a processed trajectory file or a pose file, and then it's going to build your point cloud. And then there's really nice tools in here to actually clip the point cloud by different segments. You can export it out as a LAS file from here. You can also export what's called the cam list, which, as I explained earlier, how you would then be able to geotag photos collected from your system and then process them in a photogrammetric engine to produce really high quality digital orthomosaic models. So what is LiNav? So LiNav is the embedded module I just talked about in LiGeoreference, and what this is going to do is it's essentially going to improve the quality of your final point cloud. And the way it's doing this is it's actually going to be performing a differential correction, kind of similar to what you would think of PPK as if you're familiar with surveying, on the GNSS data using that base station data either supplied by GreenValley International's base station or some third-party provider. It's going to then take that and tightly couple it with a IMU readings that are collected from the IMU in the inside of your actual LiAir payload. And then it's going to generate for you a really high accuracy, high precision estimate of what that sensor's location and attitude, yaw, pitch, and roll, was throughout the data collection time period. Since this information is really high quality, the actual resulting point cloud, which is stitched together based on this pose data, will also be very high quality. Here's just an extreme example of the type of errors that can be corrected in this information. The type of error that can be corrected in the final point cloud by actually processing the trajectory ahead of time using our LiNav module, which once again comes fully integrated into LiGeoreference. In fact, you might not even know it's running because it's such an easy to use software. It's just bring in the files and click start. If you know where your base station setup location is, it's important to enter it before you hit start. And next thing you know, probably about 15 minutes time for 10, 20 minute flight, 10 to 15 minute flight, you're looking at a georeference point cloud that's going to be extremely high accuracy. So point clouds that are collected from UAV platforms are great. You can really cover a lot of area in a short amount of time. You're not subject to all the constraints that something like a terrestrial LiDAR scanner would have, where it has to, be carried around by an individual. There's going to have to cross roads. They're going to be really running into a lot of operational barriers that just slow you down. And also, you're just limited to how fast you can walk. So UAV LiDAR is really great for providing large coverage. The only fallback in some ways is that it's always looking downwards, and you can fly lower and you can fly around objects and generate unique flight paths to get some side viewing on objects. But really, when you're maximizing the efficiency of a UAV LiDAR platform, you're flying at basically fixed AGL or height above the ground, either through terrain following or just through waypoint mission design. And you're just trying to cover large areas, and you're not going to really be capturing the sides of objects like houses or the undersides of trees, right? LiDAR is not X-ray, so if the laser is totally blocked or the object at which you're trying to measure is occluded by an object that the laser basically comes into contact with first, what you're going to see is you're going to get sort of a data hole. So what's really nice is to have other LiDAR platforms that can help fill these data holes. So in this image, you see here a colorized point cloud that was collected from our LiAir 220 system. And then you're going to see something that is colorized kind of a blue to red. So I should say colorized in LiAir is going to be true color, RGB color. If you look out in the open field area, that's going to give you that brown where this kind of dead grass was located here. The green tops of the trees or the gray tops of roofs. The subcanopy area here is illuminated or visualized with basically a color switch from blue to red, and this is captured from one of our other products, and it's a very important product for capturing the sort of subcanopy information in forests, this facade information in urban environments, and really, as I will discuss later, you'll see that there's very different technology than the LiAir, which does rely on having a strong GNSS signal or GPS signal to actually create that trajectory and then thereby create that final point cloud. What we're talking about here is our LiBackpack. This is what I'm talking about. We're going to give you that side view, that sub-canopy view. It's going to help complete those models by filling data holes where LiAir could not quite get in there just because of how it's designed and how your missions are flown. So what we're calling this is a mobile terrestrial 3D HD mapping system. It's a SLAM-based technology. So just to back up for a second on what SLAM is an acronym. It stands for Simultaneous Localization and Mapping. It's an algorithm, essentially, that's going to be able to take different sensor feeds, in this case it's going to be LiDAR, and uses that to construct a map of its surroundings, while at the same time determining where that sensor is in relation to the objects in its surrounding. So that's what the simultaneous localization and mapping algorithm is. It's a very advanced and continually advancing sort of computer vision class technology, and it's really exciting. It really allows this backpack to work in places where you wouldn't be able to use LiAir, simply because it allows you to work in areas where you have GPS denied environments. So this would be like underground mines, inside of buildings, under dense forest canopies, in cities where you're going to have blocked satellite signals from tall buildings. It's a really powerful technology, and GreenValley is really a leader in integrating it into mobile terrestrial 3D mapping systems. We've also, as you'll see as I go through these, have integrated other sensors into this platform here, including multiple LiDAR sensors instead of just having one, as our original design did. Camera, which is going to be a 360-degree 4K video, which is going to then be used to create color-fused point clouds, geotagged panoramic images, nice photorealistic walkthroughs of point cloud environments. You're going to be able to take measurements on the imagery since it's coupled with the depth information from the LiDAR. Very powerful, very useful in many situations. And then lastly, what we have is sort of an RTK, PPK, GNSS, GPS module integration. What we just symbolize as being G for probably GNSS. Just so everybody knows, GPS is a type of GNSS. We have the ability in all of our satellites and receivers to detect more than just GPS constellations. We can also detect things like Galileo and other ones that are available in the world right now for local positioning information. So this is our kind of LiBackpack 50. This is one of the very first designs we have. It's obviously had its industrial design improved, and also the internal algorithm, but the structure and what its actual features are very similar to our very first LiBackpack. And this is just going to have a single VLP16, Velodyne VLP16 sensor mounted onto a scanning arm and for data collection. So here you see it being used in actually handheld mode. So down there in that lower left-hand image, that's actually me collecting data on Crooked Street in San Francisco. If you've ever been here, you live in the area, it's a fairly well-known area. And that's actually the point cloud, a vertical cross-section being shown in the background there of this actual data collection. So what I'm doing here is putting in handheld mode. So basically I have a cable extender that's going to allow me to pull it out off that mounting bracket on the backpack itself and be able to use it in handheld mode and essentially tip it, to not very extreme angles, but move it up and down so slightly to increase essentially the effective field of view of the instrument as it scans its surroundings. So what we did with the LiBackpack 50 is we added on top this RGB 360-degree camera. Once again, this is going to be a SLAM-based system, so it does real-time registration, just like the LiBack 50 and any of the other backpacks I show. There's an onboard computer that is actually producing this point cloud in real time. It's not georeferenced, but it's going to be in local coordinate. Essentially, it's going to reference 000 is the point where you would hit start on the UI during data collection. UI is browser based and it's being broadcast from the backpack to any Wi-Fi enabled device, your phone, laptop, even a tablet if you prefer to have a larger screen. And that's going to come with our LiFuser software for image browsing and taking those measurements and actually going to post-processing to extract out panoramic images from that 360-degree data and then fuse them with the LiDAR data or point cloud data itself. And this is just a quick screenshot here that shows you what the LiBackpack C50 data looks like. It's been colorized. It's being viewed in our LiDAR 360 software, the rendering effect on it called glass mode, which makes it really nice to view this sort of point cloud data and kind of get some idea where edges are and see things like tree stems, the corners of buildings, and other things much more clearly in the rendered 3D visualization of the point cloud data. And then we have our LiBackpack D50 system. This is going to be a dual laser 3D mapping system, very similar to what our LiBackpack 50 does. It does not have a camera on it, but this is basically going to give you an advantage of being able to scan almost a full globe around you at all times. So for applications where the objects of interest are overhead, so mapping, say, power line corridors, very tall buildings, forests where I'm trying to get the tops of individual trees, buildings, many different applications where the objects of interest are more than just kind of at eye level, which will be captured well by the horizontally oriented scanner you see there on the top. The vertically oriented scanner is really going to get those objects that are surrounding you that are high up, if you want to think of it that way. The tops of trees, the tops of buildings, the tops of bridges. And it's also going to be able to capture when you have kind of an enclosed space, the upper portions of it. So if you're walking in a warehouse and you really want to make sure you have good coverage of what the rafter spaces overhead look like, this D50 design is really going to give you a lot of advantage. You're not going to have to go out there in handheld mode and struggle to make sure that you are actually getting adequate coverage of the survey area and object of interest. This one will be doing it continuously, and it really makes for a nice, easy to use tool when you're scanning in these sorts of environments. And then we most recently released this one, which is going to be our LiBackpack DG50. So what this is going to be is it's going to be our D50, and on top of it, it has that integrated kind of RTK, PPK, if you want to think of it that way, base rover survey technology. It's a GNSS module that's going to interact with a base station that's set up nearby. You can see that center circular image there. That's actually a picture of me setting up the GreenValley International base station receiver, kind of right next to the base of the LiBackpack itself. There's an antenna there that we provide. Obviously, that antenna is best to be centered over a known survey point to give you a really good differential correction and post-processing. And over to the far right is where you're going to see just kind of an example of what LiBackpack DG50 data looks like. So it is very clean looking LiDAR point cloud data. One of the things is you can't tell, at least from this image, is that it's georeferenced within 5 centimeters absolute accuracy again. And that is going to be really nice if you're a surveyor working for this, or if you're trying to get data sets to align that have been collected at different points in time to do something like change detection or to see how volumes have moved between operations. And one of the things you do see here is that we always kind of have this tablet next to it. It does have an Ethernet port on it, so you can do a direct connection to the backpack. This allows for quicker data transfer, and it's a nice, easy to use screen because as you're moving about the survey area, you can see kind of the path you've been walking, as well as a subsection of the point cloud that's being collected and its information on the instrument itself. And this is just an example again of some of the data we've collected. The one on the far right is showing you the inside of a parking garage, kind of left side of the right hand image, and then the above ground areas that were collected as well. So since it's SLAM based, you can actually move between these GPS accessible environments or GNSS accessible environments and these GPS or GNSS denied environments like an underground parking garage. And you do this seamlessly. And since you have essentially ground control data that's being collected outside of the parking lot where you have satellite visibility, you're actually going to get geo-reference points in this final data product that are in the areas in which that SLAM only data collection was occurring, if you want to think of it this way. So you'll be able to georeference points that were much more difficult to do with previous technologies. And then lastly, this is another kind of side view scanning solution that GreenValley has. It's going to be a mobile system that's going to mount to the top of a vehicle, a car, a truck. This has a Ladybug camera on it, and also features a Regal sensor for long-range scanning. This is very, very high accuracy, very capable scanning system. Once again, we ask you, if you're interested in this solution, to reach out to us directly at info@greenvalleyintl.com. Go to our website and find one of our local distributors or partners in your area, and we'll be able to sit down with you and talk about the details needed to get this sort of system or some demo or some sample data into your hand that would be relevant to you. But just to give you an idea about why these kind of systems exist and what the larger customer base we have for this product is, it's really people who are out there trying to create this HD map for autonomous vehicles. They want to use this point cloud data and the information contained within it, whether it be the intensity data, the spatial data, the distance data, to build these maps that contain features like lane center lines, lane markings, traffic signs, traffic lights, and then push them out as vectorized models that can then be used in later stages of autonomous vehicle. We also have the ability to, through some of our software tools, to actually classify these point clouds to very high degree of, a very high level. We're actually classifying things like light posts, vegetation, conductors versus poles, roofs versus facades of buildings. So this can be called something like a context-aware hierarchical abstraction. A lot of what we do are kind of machine learning based approaches to the classification and segmentation of point clouds. It's a little more advanced than I'd like to get into in this particular webinar, but once again, if you're interested in the software side solutions for something like HD-based map building, processing of mobile LiDAR data like that collected from our LiMobile system, please reach out to us at info@greenvalleyintl.com. Now, I just want to point out kind of where we are at in terms of solutions that are about generating deliverables, right? These is really the thrust of our company. It's becoming more and more aware that people just don't want point clouds. They want to solve problems, and they need point clouds that can help them solve those problems. Otherwise, they'll continue to look for different technologies or use the existing technologies they have. So in order to derive the most value and the necessary value in many cases from the point cloud, we develop different softwares for this. So one is going to be our Powerline software, and this is really targeted for the utility manager, the vegetation manager, someone who is really looking to maintain the safety and reliability of their grid infrastructure. So LiPowerline has this really nice classification tool set in it that's going to allow you to use machine learning based methods to classify point clouds to say, detect what's building, what's tree, what's conductor, what's power line, label these in the point clouds, and then those labels are important for subsequent levels of analysis that are done in LiPowerline. And these levels of analysis can include things like danger point detection. And as you see there in the lower left-hand corner image, the little red line is showing that user-defined clearance space has been violated by this tree, and this would be an area where work should be performed. You can also get that work basically output in a very user-friendly type PDF interface like you see on the right there that can be handed off to, say, a tree trimming crew to go out and actually perform the work. It can help you plan, schedule, and do all the like. Also, LiPowerline has a very advanced tool for individual tree segmentation. So you can do tree fall analysis, as you see up in the right-hand corner there, to identify individual trees that if they were to come down, could strike one of the wires or pass through the clearance zone and create a hazardous situation. We also have the ability to allow you to vectorize the asset. So that would be the towers, the transmission towers, the shield wires, the conductors, create these 3D models of the asset, and then apply some simulation that will allow you to see how those conductors, their sag and sway, will change depending on environmental conditions like ice load, wind, heat. LiPowerline is very customized software for working specifically with the managers of distribution and transportation assets, but it's also very powerful and very direct in that sense. So please reach out to us directly if you have more information. If you would like a demonstration of the software or you would like more information on it. And lastly, this is just to kind of segue into our next webinar here, but I want to end by talking about LiDAR 360. So what you can see here is a bare earth model, right? And this is actually a Li model. It's a raster, a 2D raster that's been projected in a 3D space as a Li model in our LiDAR 360 software, but it is just the bare ground. This was actually captured in a project I did in Japan about 2 years ago, a year and a half ago with our LiAir 220 system. And, as you see here, this was a densely forested area. But LiDAR has this ability to penetrate the canopy and give you really, really detailed information about what the bare ground looks like underneath. And this is oftentimes where people who move towards LiDAR or realize they need LiDAR go make that final decision, is that they need that bare ground information, that topographic information that you're going to get out of a point cloud data set. So LiDAR 360 has all the tools you'll need to classify the points in the point cloud to actually create a point cloud that's just ground points, and then build mesh models as well as raster-based models, as well as models like this 3D projections or contour models that you'll need to actually look at that bare ground information, and then you can export those out as shape files if you're working in like a GIS type environment. You can export them out as, say, DXF files in some situations, 3D object files if you're working in a CAD environment. So it's really about going from point cloud data to a deliverable or a data type that our users really need to justify the use of LiDAR in the first place. So LiDAR 360 version 4.0 was recently released by us. It's a powerful point cloud post-processing toolkit. It's built on a GPU architecture, so it works very well with very large data sets, which is, anybody who's worked with LiDAR data before knows, can be a very challenging thing. It also has the ability to script some of the tools into workflows, and then you can bring that into a command line environment. Very useful for companies that are doing very repetitious or large projects and need to break up the post-processing work into chunks. And then we have industry-specific modules, kind of like the one I discussed earlier, for professional and topographic surveyors that are going to give you the ability to create all your elevation models, as well as some really cutting-edge tools for foresters that harken back all the way back to our original product of LiForest, that are going to allow you to do things like forest stand segmentation, extraction of individual tree metrics such as height, ground volumes, and if you have that terrestrial view data available, something like the backpack, you're going to be extract out things like individual tree diameters. So there's some really powerful tools in LiDAR 360. It really does warrant its own webinar, which will be taking place on Thursday, April 2nd, 2020 at 10 a.m. So same time a week from today. I will be your host for that as well. In the meantime, please email us at info@greenvalleyintl.com with any of the feedback you have on this particular webinar. If you have any questions about the systems, if you need any demo, any sample data, or you just want to hop on a call and talk to one of our friendly account managers, someone who's available to speak with you. And we can also point you towards any of our capable partners if you're looking for some regional specific advice or just like to work with somebody who's closer to home. So thank you all for joining me here today, and I look forward to hopefully having some of you back here next week. Bye-bye.